Good evening. Today we're going to talk about the Wumpus World problem. The Wumpus World problem is a rather famous problem. It states that there's a board, in this case it's 4 by 4 on which there is a single player. He can move left, right, or at a diagonal, in this case. He's got two different obstacles, which are pits and wumpuses. Wumpuses are man-eating animals. Pits kind of speak for themselves. In order for the agent to know that a pit or a wumpus might be approaching, pits give off a breeze, and wumpuses give off a strong stench. Um, the end goal is to find the gold, and you know you're at the gold if the location is glittering. So this code was actually found online. It was done back in 2007 by Richard O. Legendy, which is an awesome name. But anyways, um, so we're going to talk through. We'll show you how it works. We'll show you how it's moving, how the agent is moving through the board, and kind of how he is, or he, the agent, is working its way through. So the first thing is just declaring the different methods that we're going to use, which are agent location, gold location, and pit location, as well as Wumpus location. Those tell us where we stand, where the goal is, as well as where our obstacles are. Our time and score, really not that important. Kind of just tells you how many steps it took for you to get through. And an associated score. Um, our visited list and visited cells lists, which specify where we've been and where we currently are, and our world size, which again is 4 by 4. So the first thing is just the start. We go ahead and we specify the game's starting position, as well as just kind of giving out a little message for the user. And the game starting position is position 1-1. So I pulled up a Word document. You can see this is position 1-1. It goes up to 1-4 and over to 4-4. We'll talk through this when we see our actual layout. First of all, we have to go ahead and specify our variables, agent location, gold location, score, and time, as well as Wumpus location. We also then specify the rules. If the agent is currently in the gold location, you win. If you're in the Wumpus location, you lose because you've been eaten. Then we go ahead and we declare step. Step is essentially like make a move. So we, using our percept sequence, we decide what we're seeing, and then go ahead and update that list if we think it's accurate. We then ask our knowledge base if we've been there before and what action we should think about taking. Then we take the action, or we decide what action we're going to take. We go ahead and we take it, and we update our location. Again, this is kind of our score keeper. Every time we move, we go ahead and we update the time. Our score is determined by if we're at the gold location or the Wumpus location and where the agent is. And we just go ahead and update our score as well. And our score is really just our score plus our precepts, our precept scores based on whether or not we've won or lost. But none of the scoring is all that important. The important thing is whether or not we actually reach the goal, or if we die en route. So we go ahead and we note here that if we're in a pit, we're going to go ahead and mark it as a pit. If we're not in a pit, it doesn't matter. Or we just say that it's not a pit. And updating the agent location, we just reset the agent to knowing that it's now at the new location that we just moved to. Down here, we once again just declare that we're going to be using Wumpus location, gold location, agent location. We say if the agent is standing within a pit, so if pit is yes, then the agent is spawned into a pit and the game fails. you've lost. If not, just go ahead and be standing, um, and leave the gold and Wumpus as they were. Um, if the agent is not at the gold location yet, but we think we know where it is, we state that there's still something to do. If the agent is in the Wumpus location, we state that you've been eaten by the Wumpus. And if the agent, as we're seeing, agent location, gold location, Wumpus location. So if the agent is where the Wumpus is located, not where the gold is located, here in the middle, you're eaten. If you are located where the gold is located, then you went ahead and found it, and you win. So this is about our precepts. Our precepts, we again stated how Wumpuses give off stenches and pits give off a breeze. I'm not quite sure why the person who wrote this code didn't write breeze. They wrote bleeze. I'm going to say breeze from now on. But anyways, so the two different types of precepts we can really take in is if it's glittering, if it is bleezy or breezy, or if it is stinky at the current location. And we go ahead and we test to see if it's any of those things. If it's any of those things, we take it into our precept. And that's really influential in knowing what our next move should be based on what we think might be around us. So we say it's either smelly from the stench, breezy from the breeze, or glittering from the glittering gold. So now we're just going to initialize our game and our board, and how everything is loaded up. Initially, just we set our time to 0, our score to 0. Our visit is actually initially set to 1 because we have the state that we're starting at. And we don't currently have any visited cells because we haven't moved yet. We also don't know where the Wumpus is located or the gold is located. So we'll go ahead and we'll lay out the board. We said the board has a size of 4, meaning it's 4 by 4. Our gold is in location 3, 2. Our pits are in locations 4, 3, 3, 4, and 1, 3. Our agent starts in 1, 1, and our Wumpus is in 4, 1. So if we come look at the kind of just the chart I drew out, you can see that Wumpus is in 4, 1. The pits are here, here, and here. Pits in their surrounding areas give off breezes. So the Wumpus gives off smelly, but the pit here gives off breezy. So this spot is extraordinarily dangerous as it's both smelly and breezy. This is the gold, and therefore it is glittering. There's nothing in these two blocks. So those are the safest non-victory states, as it were, besides the one that we're currently in. Sorry, let me get back to the code. So that's our board. Then we just have our visited cells, whether or not we visited, and how we assert a cell as a visited cell. We also say which cells are adjacent to each other, so how we can move one to one, essentially. So all the ones are next to the twos, all the twos are next to the ones, all the threes are next to the twos, so everything in column 3 and row 3 are next to the things in column 2 and row 2. So then we go ahead and we start mapping out our precepts. So we go ahead and we say that if the location that we're currently at is smelly, the adjacent location may hold a Wumpus. So if location 1 is smelly, location 2, in this case here, could be or is a Wumpus. If it's glittering, then the gold location is in the same place, so glittering is associated with gold. If it is, sorry, wrong thing. And then if it's breezy, then the spaces adjacent to the pit are also breezy. So if it's breezy in the agent location, or if the agent senses breezy, it's also breezy in the agent location. If it's smelly, it's also smelly in the agent location. If it's not, then the agent doesn't really take in anything. If it's glittering, then it's also glittering where the agent is. Here's where we actually update our knowledge base. So here's where we say whether or not we think it's a pit. So just coming down here, we add to the knowledge base that if we don't think that there's a Wumpus around, then we don't have to. So therefore, if we don't think it's smelly, or we know it's not smelly, then we don't assume that there's a Wumpus in any of the adjacent spots, whether up, down, left, or right. The opposite of which being if it is smelly, and we have to assert that there is a Wumpus. We do the same for pit. If it's not breezy, then we assume that the adjacent spaces do not have a pit. If it is, we assume that they do. If it's not glittering, then we assume we're not at the gold location. But if it is glittering, we assume we're at the gold location. Again, all really simple. This is just kind of what we print out. So if we assume that there's no Wumpus there, we go ahead and assert that there's no Wumpus at the current location, or at the location that we're assuming that there's none, and we just kind of state that based on our percent. Again, if we assume that there's a pit or gold, anything like that, then we have to ask if moves are permitted within the world, so whether or not they're within the world size. Then we go ahead and we ask our knowledge base to test if a move is okay. We gotta make sure that we're not going to run into a pit, so we make sure that there's no Wumpus at the location that we're trying to move to. We make sure that there's no pit at the location. We make sure the location is permitted, so therefore we make sure that it's within our world size. Then we go ahead and we just update the location. We make sure that we haven't visited it before, not member. Then we go ahead and we visit the location and actually take the action. So we'll run through the code really quick. After we test it, we'll kind of see how our agent is moving around on our board here. So we'll go ahead and we can compile. This code does have some warnings about single variables. It's not an issue. Still works just as we'd like. Give me 1 second. Let me relaunch. Sometimes we have this issue.